Okay, welcome Algebra 2 students. This video is going to be about solving fun word problems, all about radical equations. So we're going to use solving radical equations like you've been practicing earlier in the week to now apply it to fun word problems. If you don't have me as a teacher, it's Miss Skelton here again. I always say fun before word problems to try to train my students' brains to not be scared and to think that they're fun. It's just a little subliminal messaging, so hopefully it's worked throughout the course of the year. Okay, I went ahead and already wrote these out. They're also in the notes, so you can write them out first if you want, or if you don't want to write them at all, that's up to you too. So here we go. Number 1, in a hurricane, the wind velocity v is given by v of p equals 6.3 times the square root of 1013 minus p, where p is the air pressure. So in all of our problems today, we're going to have two variables. Here we have v for wind velocity and p for air pressure. And the equation is going to have some sort of radical or exponent in it that'll relate to the unit we've been studying. We have to decide, based on the information given, where to plug it into the problem. So this says estimate the air pressure. We want to find P with the wind at 54.5, and I'm assuming that's miles per hour, but it didn't say. So it's giving me the speed of the wind, the velocity. So let's go plug that in for V. So in my equation, here's my air pressure. V of P is my velocity. It's my dependent variable. And so I'm going to go ahead and put 54.5 there instead. The rest of the equation stays the same. And then we're going to use our solving steps to isolate P, the air pressure. So remember, we have to get the radical by itself first. So I'm going to cancel the 6.3 by dividing both sides of the equation by 6.3 to make that cancel out. Get a calculator over here, 54.5. divided by 6.3. Okay, we're going to go ahead and round that to the nearest hundredth. Let's keep it at 8.65 equals the square root of 1013 minus p. Now we're ready to cancel our square root. So the opposite of square rooting would be to take both sides and square. And so the right side, we're going to just have our 1013 minus p once the square root and square cancel. On the left side, I'm going to take 8.65 and square it. And here, let's go ahead and do the same. I'll keep the same rounding of the nearest hundredth, so 74.82. And now we have a two-step equation to solve. So I will subtract the 1013 from both sides. Giving me negative 900, I'll move it over here, 938.18. And on the other side, I still have P and it's negative. So if we know negative P is negative 938, then positive P is positive 938.18, or I think in the notes it's rounded to 0.2. Remember, this is the same as if you just divided both sides by negative 1. So we just found that the air pressure, although it doesn't tell us what units that's in, is going to be 938.18 or 0.2. Okay, great. So notice the equation was given, we decided what to plug in, and we solved. Let's see how else we could use the same type of thought process. Number 2 says the length L of a nail can be modeled by L equals 54d to the 3 halves power, where d is a diameter. So here we're talking about the length of a nail and like the diameter of the circular top part. What is the diameter when the length is 3? Okay, so it's telling me L is 3 and find the diameter. So let's take 3 and plug it in for the length. Okay, and then we're trying to solve for d, the diameter. So I have to make sure I get that the variable d that has the 3 halves power isolated before I cancel the power. So just like on the last one, we're going to divide first. And then I'm going to have d to the 3 halves power equals, whoops, 3 divided by 54. Okay, that's kind of a crazy number. We can either round it or we could just leave it a fraction. If you're on a graphing calculator, math, enter, or we could reduce the 3/54, divide both by 3 to 1/18. And then let's talk about how we cancel a fractional or rational exponent. So remember from our last video, we said we want to use the inverse power, meaning I want to take the 3 halves and use its reciprocal. Flip that rational power and apply it to both sides. And that will leave me with, back to the calculator. You can, if you have it on your screen, just hit to the 2/3 power. I'm going to type it. So 1/18 to the, make sure you're using your exponent button on the right side. If you're on a graphing calculator, you can do this on a normal calculator too. And I get 0.1455. So we'll go ahead and round it to approximately 0.146. And again, we don't have units in this problem, but that's okay. We solved for the diameter, and we can go from there. So we got 0.146 for the diameter when we isolated d. All right, the next part says, what is the length when the diameter is 0.9? So same equation. This time we don't know the length, so the goal is find L when the diameter d is 0.9. So let's go plug that in and see what that's going to look like. Back to my original equation, 54 times 0.9 to the 3 halves power. And this one's nice because I don't have to do any solving. L's already by itself. So if I can just figure out what number this is, then I will have my answer. If you are not using a graphing calculator, just make sure you do order of operations. You do the exponent first, see what you get, and multiply it by 54. I'm going to type it all at one time. And get 46.10 or 0.1. So I'm guessing, although it doesn't give us any units, if we're talking about a nail, I'm guessing this is like 46 millimeters. Otherwise, centimeters, that would be crazy, and it definitely can't be inches or anything like that. But again, we're not focused on the units today. We are focused on, can we figure out where to plug the numbers and then how to solve the equation. Okay, 2 more. All right, the next one has some adventure in it. We can use the equation y equals negative 4.9t squared plus 14,500 for skydiving, where y is the person's height above ground and t is the time in seconds. Determine how long until you reach the ground. Okay, so we are looking for how long. We're looking for the time. So our goal is to find t, and that means we must know y. We must know the height. So think about when you reach the ground, what would your height be? It's the person's height above the ground. If you are on the ground, your height would be 0. You're not above the ground at all. If you're taking physics, you probably have done some problems like this, or maybe even more complicated, where you're writing an equation yourself. So we know y is 0. I'll put a 0 there. I'm going to leave t in my equation because we're trying to find the time. Okay, even though this equation doesn't start with a radical, we'll still get to use a radical to solve. So let t by itself. Cancel the 14,500 by subtracting it on both sides. So I get negative 14,500 equals negative 4.9 times t squared. Before I cancel the square, I'm going to have to cancel the negative 4.9 that's multiplying times the t squared. So I'll do the opposite and divide both sides by negative 4.9. Negative 14,500 divided by negative 4.9. Okay, I'm going to go ahead and round to the nearest hundredth again, so that's 2,959.18 equals t squared. Now to cancel the square, I'm ready to use the square root on both sides of the equation. Okay, if you want, sorry, that was an incomplete thought. I was going to say if you wanted to take the square root of the number on your screen, but since we already rounded, I'm going to type the rounded version of the number, take its square root, and we get 54.39, so I'll say 54.4, and again, units are missing. Probably, if you're skydiving, I would estimate seconds, but again, we're focused on, can you decide what we're solving for, what we're plugging into the equation, and then how to actually isolate a variable. All right, so the final one is going to remind you of your days back in geometry. It says, determine the diameter of a circle if the area is 94.985. Okay, so that's going to make us recall the formula for the area of a circle, which is pi r squared. And the equation says determine the diameter. All right, so our goal is to find the diameter. The area is given, so I'll go ahead and plug that in. And then it says, let's use 3.14 for pi. So notice once we solve this, which isn't that hard to do, we will find the radius. And we'll have to make sure at the end that we then use that to find the diameter. Okay, so to isolate r, let's divide both sides by 3.14. And I get, a nice number, 30.25. And now I can take the square root of both sides in order to cancel the squared on r. Square root, square root. All right, and we get 5.5 for the radius. So remember, the radius is from the middle of the circle to any point on the circle, and the diameter is actually all the way across. So we'll have to take, for the diameter, take the radius that we just found, double it, and it looks like we're going to get 11. So 5.5 twice would give us 11 all the way across. Okay, hopefully this video helps. Pay attention when you're doing practice or a skills check or quiz as to what it asks you to do for rounding, and of course we're going to be lenient on that as well. So go ahead and try the practice, check your answers as you go, ask your teacher if you have questions along the way. And of course, I hope that we can all be together again soon.